Hello everyone. We're going to have the webinar, installations, tips and troubleshooting and the best practices from Edna. She's the product manager in SAMLEX, and we're going to start the webinar with her. Thank you, Edna, for your next presentation.
Thank you, Hector. Well, good morning, everybody. Thank you for attending today's webinar. I'm Edna, and I am an applications specialist at SAMLEX America. I've been with the company for a couple of years, and I am here today to briefly talk about some of the installations we've encountered. And we do hope you find this information useful and help you with your own power systems. So a little bit of housekeeping. This presentation is only a guideline based on inquiries we have received from our valued customers. Please follow all rules and regulations specified for your country. What we will see in this presentation, we're gonna talk about two products, which is power supply and inverters. And we will talk about the most common inquiries and some of the troubleshooting process from our side. Also, a couple of examples of installation practices that are not the best ones. So you can take note and we will all learn from those. Lastly, but not least, we will have a Q&A session at the end of the presentation. And if I am not able to answer all of your questions today, or inquiries, please send those to Hector and we will make our best to get back to you ASAP. So power supplies, most common inquiries. One of those would be, what is the difference between the SEC 1235M and the SEC 1235P-M? So there is a document online we can share with you after, but just a brief description of it would be these features. Aside of the meter, which in the P-M, the backlight of it can be lit. The main difference is that in the AC input of the unit, the 1235M can work with 120 or 240 volts DC, but that is to be set by the user. So the user would need to open it and change the switch and change the fuse of the unit. Whereas the 1235P-M, it is already, the input of it, it's universal. So it's prepared to receive the 120 or the 240 without the user needing to open the unit, nor switching the fuse, nor switching anything else. Aside of that, we can say that also the SEC 1235P-M, it was designed with efficiency being the focus of it. It does meet the minimum energy performance standard, and also it is certified as an efficiency level 6 unit, which means that it has lower power consumption with no load connected to it. And it is also UL listed as the previous one, and it is CE certified for the unit being used in Europe as well. Next one, most common inquiries on power supplies would be regarding how to troubleshoot the power supply, or how do we troubleshoot the unit. I have two cases on this, only two, and the first one would be when turning on the unit, the power supply, if the switch is not lit and the load doesn't turn on. So there's a couple of causes for this. First would be that there is no AC from the grid, or you're not getting AC power from the outlets. So to verify this, you need to grab a multimeter, check that you do have AC. And if that is something you don't want to do, you can use good the good old trick of having a desk lamp and connecting it. If it turns on, then you have AC. And if it does not, then you have a bigger problem. Second cause would be having the AC side of the AC fuse in the unit blown. To verify this, you would need to open the unit, look for the AC side fuse, which I am pointing it right there, and replace it if blown. You can find the exact fuse to get in the electrical spec of your unit, which can be downloaded from our website. And the third possible cause we're going to talk about is that the unit shut down due to over temperature. Sorry, I couldn't find a way to take a picture of that, but this case is hard. It's a hard one for the unit to recover from. It protects itself and it shuts down. It will get back to function once the internal temperature of the unit gets back to its normal. Two possible causes of the unit shutting down due to over temperature. It's that the vents are blocked and that the load is that you have connected to our unit, it's drawing way too many amps. So you have an idea. We have found some users. Just so you have an idea, we have some users that do have even fridges connected to our power supplies. There are some DC fridges. It's a practice we personally don't encourage that. We have not tested for the performance of the unit in that environment, but we have found those. Second case of the most common inquiries in power supplies would be when the unit turns on, the switch lights up, but the unit in the meters, it's in hiccup mode. We call it hiccup because it goes up and then shuts down and then goes up and then the voltage goes back to zero. So that's what we call the hiccup mode. And possible causes of that would be first that the unit is overloaded. So to get out of this mode, we need to reset the unit. So turn off the unit, wait some seconds. I usually wait longer than needed and turn the unit back on and measure the output. You should receive a steady 13.8 volts DC in the output. If this fixed the problem, do verify that the electrical specs of your load, as it might be outside of the parameters of our unit. Second cause would be that there is a short circuit on the load side. So switch off the load, check the integrity of the cables, and very important, make sure you're using the provided PT and B terminals of that came with your unit. We're gonna see a little bit further. We're gonna see deeper on that further ahead. Another thing that we get inquired a lot, it's how to change the voltage. So the unit, some of our units, the voltage output can be adjusted from 12.5 to 15 volts DC. So you gotta open the unit, and there is, with a Phillips 1 screwdriver, there is a little component there, which is a VR1. I am pointing it there, and you can turn it left or right until you get your desired voltage. Installation mistakes of the power supplies. This is just an example of not using the PT and B terminals that came with our unit. It is so the excess of resistance to generate heat, and heat, it's a risk of fire. So always use the PTNP terminals. We do encounter those not being used as they should be, or instead of crimping them, like kind of crimping them. So let's play it safe and always use the right terminals, and also crimp them correctly so you don't have these type of cases, right? Okay, moving on to installation of inverters. So most common inquiries on those, case one, switching on the inverter with no load. Then, oh, sorry. So case one, it is why my inverter have a constant high pitch noise. This means that the unit is buzzing and it is in a fault state. And you switch on the inverter, there is no load, and you hear this high pitch noise. So LED is on, status LED in the GFCI is green, meaning it's working. And this is only if applicable, because some of our units do not have a GFCI outlet. So in case you do when it is green, meaning that everything is perfect, but you still get this high pitch noise. So you have a low DC input voltage alarm. First things first, you need to check the voltage of your battery, because if the voltage of it's lower than what it should be, the unit is gonna fault. So with a multimeter, go check the voltage. In this case, I don't know if you guys can see enough, but it was 12.53. And to verify that your battery is in the right voltage, right? Second, make sure you're using the right port and terminals. I cannot extend that like enough. If you're not using them, install them and try it again. Pull the cables a little bit to make sure they are tight. They should be snug. They shouldn't move at all. There should not be any play, or they shouldn't be loose. And if all that was okay, with a multimeter, we can measure the drop voltage from the battery terminals to the input of our units. So the difference should not be higher than around 0.5 volts. We usually use those in percentage, but to make it easier to explain it today, if the difference is higher than 0.5 volts, then what you do have, you're using the wrong size of cables. So you're getting more resistance from the wires, or the cable is too long, which also causes more resistance on the wires and the connections. So it can be that also the DC cables are not flush to the inverters, DC terminals. We're going to see an example of that. And there might be some corrosion on the batteries, and that will cause a bad connection of the wires, and the battery is getting close to the end of their life also can be a possibility. So the next ones are going to be a couple of examples that we have seen also in the installations. So the first one is a 2000 watt inverter, and the wires that were being used were very thin. I don't recall the size, but you can see the difference in the third picture, what the customer was using versus what they should have been used. So it's pretty, you can see the difference. Second, not using the adequate port and terminals. So this, we do see it a lot. Units faulting because of not the customers or the end users not applying this, not installing this. And again, those are most likely, those are provided with our units. Please use them and crimp them correctly. The second picture, like the picture on the right, it's an EVO, the terminal block at like having the cables just old school, trying to put them in, and it just does not work, and it is not safe. This example, it's a little bit trickier to find, but we have seen it. On the first picture on the left, you can see that there is a slight gap. So the terminals should not only be touching metal to metal, it should be entirely flushed. The more surface that is touching, uh, that's the way it should be. So in the first picture from the left, there is the negative terminal. It is entirely flushed to the unit, which is correct. Whereas the second one, the cable, because I know that cables are thick and they are hard to manipulate. So this person like flipped it or installed it backwards, and it created a gap. So it was just touching with very little metal. So that's not okay. That would also trigger the unit to fault. The picture in the middle, there is also, we can see a very small gap on the wire on the DC input, the positive terminal. Again, hard to find, not hard to, yeah, that would be a hard to find cost, but always check on that. And the third picture is just an example of how we have it here in the lab, just entirely flushed. The last one, it's regarding the corrosion. So it does make a difference having well-maintained terminals. So in here, the batteries should not be exposed like that. But aside of that, the terminals are corroded, which makes more resistance on it. So always maintain your battery terminals. If they are not maintainable anymore, change them. Having proper connections. The key, I think, it's in the connections on most of the installations we have seen. So that is all I have to share.
Okay, thank you, Edna. Thank you very much, Edna, for your time and for sharing all these tips and advices. And thank you to those who attend the webinar. And that is everything for today. And have a great weekend.